And so the first thing they talk about here is what is a quadratic? A quadratic function is a function that can be written in the form y equals ax squared plus bx plus c. So you'll notice in a quadratic you have a squared. When we talked about linear equations, you just had x to the first power, y equals mx plus b. All right, and so when you see that squared, then you know you're dealing with a quadratic. This is the standard form of the quadratic equation, or quadratic function. And so this right here, ax squared plus bx plus c, is the standard form of a quadratic function. And you will use that when we start graphing these in the next section. So the first thing they do is they talk about the graph of a quadratic. A quadratic function has a U-shaped curve, and it's called a parabola. And so this graph right here that looks kind of like a U is called a parabola. And that is what you will get every time you have y equals x squared. They may shift around, which we're just going to do some. They may get skinnier and wider, but they will always be in this U-shaped form when you have a quadratic function. Let's look at some more terms. Top of page 7. Quadratics are symmetric, all right, which means that they are identical on one side and the other. And so when you have this type of symmetry, you will have a line that you can draw right in the middle of it, and that's called the axis of symmetry. And so every point will be exactly the same distance away from that line because they will be like a mirror image of itself. The highest or the lowest point is your vertex. That's where it turns. So when you have that U shape, your vertex is where it turns. If it's pointed up, it's going to be a minimum. And if it's pointed down, it's going to be a maximum. All right. And so that makes sense if you were to draw it. So if I have something that's pointed up in a U shape, then I have a minimum point. If I have something that's pointed down in a U shape, then I have a maximum point, because my highest point or my lowest point will always be my vertex. Always be my vertex. And that's where the minimum and maximum come into play here. All right, let's look at how we use this, identifying it. All right, it says identify the vertex of each graph. Tell whether it is a minimum or a maximum. So when you're identifying the vertex, you are literally going to look at the point where it turns. And so we're going to see this one right here. This is where it turns. And so that was the vertex, which is 1, -2. 1, -2. And because it points up, meaning every other point on the graph is higher, which would be up here, then that point is a minimum. That point is a minimum. Look at B. B points down. So the vertex is going to be where it turns. This would be the vertex, which is where they get -2, 4. -2 and 4. So that is my vertex, and it's pointing down, and it is the highest value on this graph. And so that is a maximum there. It's the highest value. So go ahead and try A and B there under check understanding 1. All right, for the first one, for your vertex, you should have gotten that it was at 4, 3, and that it was a maximum. And then for B, your vertex happened at -3, -3, and that one was a minimum. If you look at the bottom of page 511, it talks about graphing these quadratics, and we are actually going to sketch these using some shortcuts. We did some graphing of these a few chapters back where we were doing graphs. We did linear graphs, we did parabolas like this, and we did the V shape for the absolute value. And part of the problem that you saw when you were graphing these is that if you did not pick the right values, then you would think it was a line because you never turned, right? And so when you were graphing these before, if it didn't go right at 0, then there's possibility that you could just get these points and you might think you have a line. And so if you know now that this is an x squared and that it's going to be like this, then once you graph these, if you figure out this axis, then you know that it's going to be exactly symmetric across. And so the way they do it here is they just pick points and they plug them in. All right, we're actually going to use some shortcuts to do it, but I wanted to show you the symmetry here. So if you find your vertex, which we're going to do a shortcut to do that, and you find 1 or 2 points, then you can just count across. Like this is 1 away from my symmetry, axis of symmetry, so the other point's going to be 1 away. This one is 2 away, or technically 4 because they're every 2. So it's 4 away from my axis of symmetry, so this other side is the same distance. And so when you start graphing these, because you know they're symmetric, you don't have to graph all your points. You can graph some and then just reflect it across. All right. Let's look at how these change. So depending on what's going on at the very beginning of it, they might look different. This is your standard one over here on the far right, y equals x squared. You'll notice this is the perfect little u. It's right at the 0, 0, 0. My origin is where it starts. And it's just a normal looking parabola. When they multiplied it, oh, it went away. Let's see. When they multiplied this by the 1/4, you'll notice it got wider. All right, so when they multiplied it by the 1/4, then this widened it from the original. And then when they multiplied it by a 4, it actually got really skinny. All right, so a whole number in front is going to make it smaller like this, skinnier towards the axis. A fraction in front is going to actually make it wider to the axis. You'll also notice one difference over here. What's different between this and the other two? Between the first one and the other two, what's different? It's pointing down. This is a negative in front, all right? And so if there's a negative in front, that automatically tells you it's going to point down, all right? So these both had positive 1/4, points up, positive 1 points up, negative 4, it pointed down, all right? And so you'll always know whether or not it's going to point up or down by whether it's a positive or negative in front, all right? And then one more thing about the graphs. So they graphed 2x squared, which was this red graph. And then they graphed 2x squared plus 3, which was this blue graph, all right? What's the difference between these two? Where they are, right? So this started at 0, 0. They added 3 and it moved it up 3, all right? And that's what happens with these. They will move around based on what's going on. So your vertex is going to have something to do with where you are on the graph and with your standard form, all right? And so we're about to do some shortcuts with these. So the first thing they introduced here is how this standard form relates to the other things in my particular function and in my graph. And so they've given us this in standard form, y equals ax squared plus bx plus c. And they are telling us that the axis of symmetry for this particular graph is going to happen at negative b over 2a. So if I take the b, the number in front of the x, and change the sign, and put it over 2 times the number in front of the x squared, I can find out where my axis of symmetry is. All right, so that is where I'm going to reflect. What you'll also notice is that it's going to tell you where the vertex is going to be. If you take that number and plug it back in, you will get the vertex. And so we're going to look at a couple graphs here and how to use this to sketch the graph of the function, all right? The third thing I want to point out here that they don't tell you is this C represents where you cross the y-axis. It's your y-intercept, all right? And so by given this, they've given you your vertex, your axis of symmetry, and where you cross the y-axis. So look at example 1 on page 518. All right, example 1. What we're going to do here is we're going to find the axis of symmetry, we're going to find our vertex, and then we're going to find our y-intercept. And once we do that, we're then going to graph this, all right? And so we're going to do this a couple times so we get the hang of it. So the first thing we want to find here, it's very, very simple, and that's my y-intercept. My y-intercept is the easiest thing to find. My y-intercept is always going to be this number right here. As long as it's in standard form, my y-intercept is going to be that number. And so since that's a positive 5, my y-intercept is going to happen at 0, 5. All right? And so that is going to be a point on this particular graph. 0, 5. All right? Easy enough? Then we're going to find our axis. So our axis is a little more difficult. We're going to take this number right here, this 6, and we are going to negate it. It is a positive 6, so we're going to make it a negative 6. We're going to put it over 2 times this number right here, negative 3. So 2 times negative 3. So I end up with negative 6 over negative 6. How do I reduce that? Just positive 1. So that tells me where my axis is. Now my axis is a line. It's not actually part of my graph. It just tells me what to do with my graph. So at the line x equals 1, I am going to draw a dotted line. All right? And so I'm going to draw this dotted line. It's just going to tell me what I am going to reflect across here. So that is my axis of symmetry. All right, axis of symmetry there. And then I'm going to take that 1 and I'm going to plug it back into my function. So I'm going to say y equals -3, 1 squared, plus 6 times 1, plus 5. All right? So that's what I'm going to do to find the other point that I need. So 1 squared is easy. That's just 1 times -3. Plus 6 times 1. We're just doing order of operations. That's 6. Plus 5. So I have a -3 plus 6 plus 5. That gives me 8. All right? And so this tells me where my vertex is. Remember, your vertex is where this thing turns. Your vertex is going to be the combination of these two numbers. This is my x value, and this is my y value of my vertex. So my vertex is going to happen at 1, 8. 1, 8. And so I'm going to find that point on my graph, and I'm going to put that right there. That is my vertex. All right. This is my y-intercept, my vertex, and my axis. All right. And so now I'm going to actually be able to graph it. Here's how I do that. Remember I said this is symmetric. So as long as you have the vertex and one other point, you can just reflect the point. So if I look at this y-intercept right here, how far away is it from my line? Well, it's 1 point away from my line, right? And so I can just graph right across 1 point. That point should be there. It should be symmetric to that dotted line I just drew. So because this point right here is just 1 away, on the other side I should have an identical point 1 away from it because it is reflective, okay? It's symmetric. Which way should this one point, up or down? Down. And I know that because of this, right? The negative tells me this is point down. So if I were to look at this, my vertex, if I were to draw from here down and from here down, that parabola is going to be pointing down. And so to finish this out, I'm just going to connect those and sketch it down. All right, and you'll notice it's kind of a skinny parabola. Yes, I have a whole number that's greater than 1, absolute value greater than 1 there. So it should be a little bit skinnier. It is shifted, and it's shifted to the 1, 8 as my vertex, and it's pointed down like it should. I have my y-intercept there. And so that's how you sketch it. You find those 3 things, and then you are going to graph it based on that. You're going to find your vertex, your axis of symmetry, your y-intercept, and then you're going to reflect the point. Now, if your vertex falls on the y-axis itself, then you need to pick one other point. But I don't think they gave you any of those yet. We'll do some of those. All right, so look at the bottom of page 518. It wants you to graph x squared minus 6x plus 9, all right? So for this, I want you to find the y-intercept. I want you to find the axis of symmetry and the vertex. Put all of those on your graph and then sketch the graph of the function. All right, so they've given us the graph f of x equals x squared minus 6x plus 9. So we want to find our y-intercept. Your y-intercept should have been 0, 9. So we're using the C here. 0 and 9, 0, 9. Then for your axis, you're going to use the negative of this. This is already a -6, right? So if I make it a negative of a -6, that's actually going to be +6, right? Over 2, and my a here, if you don't see a number in front of a variable, what is that number? 1. So I end up with a +6 over 2. So what is my axis here? 3. So x equals 3 is my axis. And then the last thing I'm going to do is I'm going to plug that in And so I'm going to say for my vertex, I need to do 3 squared minus 6 times 3 plus 9. All right. 3 squared is 9. 6 times 3 is 18 plus 9. You end up with what here? 0. So my vertex is going to be 3, 0. Remember, this is the x value of my vertex. This is the y value of my vertex. All right. And then we're going to graph those. So 0, 9, that happens right up here. 0, 9. My axis, that's going to be at x equals 3. It's actually a vertical line at positive 3. So that's going to happen right here. So this is my vertex, my axis of symmetry rather. So that's my axis. All right. And then my vertex is going to happen at 3, 0. Your vertex should always happen on your axis of symmetry. And then since I already have my y-intercept up here, all I have to do is count how many units away it is. So it's 1, 2, 3 away from this line. So if I go 1, 2, 3 over, I can put a point right there as my other point to graph to. All right. And then to sketch that graph, I'm just going to do the U shape of my parabola here. So that's what that should look like. So on a quiz or test, y-intercept of 0, 9, axis of x equals 3, and vertex of 3, 0 would be the 3 things you're looking for, and then the graph should follow what you found there. So you'll notice here that instead of an equal sign, I have a less than or equal to. And so this automatically tells me it's not equals, it's going to be inequality. All right, and this is the same concept as when we graphed linear inequalities. If you have the or equal to, it is a solid line. If you have the just greater than or just less than, then it's a dashed line. In this case, it's going to be a solid parabola or a dashed parabola. And then less than is going to be under the parabola, greater than is going to be above the parabola. So it's exactly the same concept, it's just we're doing it with parabolas instead of lines. So we're going to do the same exact thing we just did. We're going to find our y-intercept, we're going to find our axis, and we're going to find our vertex. All right? So for this one, what is my y-intercept? What's my c value here? -4. So make sure that if you have a negative in front of it, that you include that as part of your y-intercept. So the y-intercept is going to happen at 0, -4. For my axis, I'm going to have negative b over 2a. So the negative b over 2a, which is going to give me 3/2. All right. And then for my vertex, I do have to plug in a fraction, which is okay. So my vertex is going to be 3/2 squared minus 3 times 3/2 minus 4. And so to remember, when you square a fraction, you just square the top and the bottom. So it'd be 9/4 minus 9/2 minus 4. What do I need when I do fractions? When I add and subtract fractions, what must I have? Common denominator. What is my common denominator between 4 and 2? 4. So I can leave this the same. I multiply this by 2. And I actually multiply this by 4. All right. So I get 9 minus 18 is -9. Minus 16 is -25/4. And we'll talk about graphing these. So that's my y value. That's my x value. All right. So my y-intercept is simple, right? 0, -4. My axis of symmetry, 3/2. If I were to make that into a mixed number, that is 1.5, right? And so I'm going to graph, it's a sketch, so I don't have to be exact, but my axis is going to be right in between the 1 and the 2. In between the 1 and the 2. All right. And if I were to make 25/4 a mixed number. So if I were to do this as mixed numbers, it would be 1.5. And then 4 goes into 25 how many times? 6 with 1 left over, right? So just below the 6 is where my vertex is going to be. So it's going to be right here on my line just below the 6 right here. All right. And then I can graph one extra point. I know that my y-intercept is about 1.5 away. So it should fall over here if I were to mirror that right here. And so my graph should look like this. I'm going to graph it exactly the same. All right. It's solid because it's or equal to, right? Or equal to means it's a solid line there. Now I have to decide how to shade it. So if I'm going to look at this right here, y is less than or equal to, where do you think I'm going to shade this? Less than or equal to? Underneath it. And so it's actually going to be all underneath this right here, anywhere underneath my y value. If it were less than, it would actually fall inside of it. I mean, greater than, it would fall inside of it. All right. So you graph it the same. You just decide where to shade at the very end. So they've given you 2 to graph. They've given you A and B. One is less than or equal to, just like this one. And the other one is greater than. So bottom of page 519, graph 3A and B. For the first one, your y-intercept should have been at -5. So 0, -5 here. Your axis of symmetry would have been at -2 over 2 times 1. So you'd have gotten just -1. So it should have looked something like this. And then your vertex, when you plug in a -1, you get -1 squared plus 2 times -1 minus 5. So you get 1 minus 2 minus 5, so -6. So your vertex should happen at -1, -6 right here. And then you can mirror that y-intercept over there. This should be solid because it is or equal to. So solid parabola here. And because it's less than, you're going to shade underneath it. All right. For the second one, your y-intercept happens at 1. So your y-intercept is 0, 1, which graphs right there. Your axis is going to be -b, which is a 1, over 2 times a. So you get an axis at -1/2. I'm going to make this a little bigger. All right. So -1/2 happens right here. And then your vertex, when you plug that in, you get -1/2 squared plus -1/2 plus 1. So you get 1/4 minus 1/2. So if I make that with a common denominator, that's minus 2/4. Plus 1, common denominator is plus 4/4. So I get 3/4 there. So my vertex happens at -1/2, 3/4. So that is going to be about right there. And then I can graph that other point there. This one's also pointed up, but it is not an or equal to. So when you graph this one, you actually want to dash that parabola. Dash it like this, all right? And then your shading happens greater than. So your shading actually will be inside the parabola here. Because everywhere that keeps going, it's going to be greater than that. So your second one should have looked something like that.